Hey guys, in this video we will discuss limiting reactants.
What is a limiting reactant? A limiting reactant is one reactant that limits or restricts how much the reaction can occur.
Essentially, it determines the amount of a product that can be produced.
In order to recognize this limiting reactant, you should do these things. Step number 1. Notice how much product each reactant can make. This can be done by converting grams to moles and then moles of reactant to moles of product. Next, determine which produces the least amount of product, and that's the limiting reactant.
Now that you know the steps, let's practice. Given the chemical equation C5H12 plus 8O2 yields 5CO2 plus 6H2O, if there's 2.29 grams of oxygen and 1.65 grams of pentane, what is the limiting reactant? What is the mass of carbon dioxide produced? Pause here and give it a try. Now that you've had some time, let's go over it. Starting with oxygen, set up a dimensional analysis chart to convert from grams O2 to moles O2. Make sure you're using the molar mass for oxygen gas. Once you're in moles of O2, you need to use the molar ratio of O2 to one of the products. In this case, we chose to find the molar ratio of oxygen gas to carbon dioxide. Remember, to find the molar ratio, look at the number of moles of each substance in the reaction. Because there's 8 moles of oxygen and 5 moles of carbon dioxide, the molar ratio is simply 8 moles oxygen to 5 moles carbon dioxide. Using this, we can determine that the moles of carbon dioxide produced from 2.29 grams of oxygen is 0.0447 moles of carbon dioxide. Now, repeat this process for 1.65 grams pentane. First, convert grams of pentane to moles of pentane. Next, use the molar ratio 1 to 5 to convert from moles pentane to moles carbon dioxide. This should result in 0.114 moles of carbon dioxide. Therefore, the limiting reactant is oxygen.
And this makes sense because limiting reactants, by definition, limit how much a reaction can occur. And therefore, if the oxygen can produce less CO2 than the pentane can, the oxygen runs out faster, and therefore, it's the limiting reactant.
Now, to determine the maximum mass of carbon dioxide that can be produced, we need to use the amount of carbon dioxide produced from our previous work, 0.0447 moles of carbon dioxide, and convert back to grams. You should end up with 1.96 grams of carbon dioxide as the maximum amount of CO2 from the reaction.
Alrighty, so let's try another one. If a reaction between iron and oxygen yields 92.17 grams of ferric oxide, what is the limiting reactant? You should pause here and give it a go. Alrighty, so starting with iron, we begin our dimensional analysis with the grams of Fe2O3. Then convert from grams of ferric oxide to moles of ferric oxide. Next, use the molar ratio to convert from moles of Fe2O3 to moles of iron. This will produce 1.15 moles of iron. Repeat the same process, but convert from grams of ferric oxide to moles of oxygen instead. This shall yield
0.1865 moles of oxygen.
Now that you have the moles of both reactants, you can assume that oxygen is the limiting one because there are fewer moles of it, meaning it will run out faster. Also, moles allow you to effectively compare between two reactants because it accounts for number of atoms.
It does this by using Avogadro's number, which we've already learned about, and that tells us that for every mole of something, there's 6.022 times 10 to the 23rd atoms or molecules within it.
But, is there a faster way to get here? Yes, because if we take a look at the chemical equation, there are fewer moles of oxygen than iron as dictated by the coefficients.
Now, using the same problem, find the amount of excess iron that is left over after the reaction if there was initially 78 grams of iron. Earlier, we converted from grams ferric oxide to moles of iron. Using that value, 1.15 moles of iron convert from grams to moles. To find the excess, use the formula initial minus used equals excess. The initial is the amount that the reaction began with, in this case, 78 grams of iron. The used amount is the amount used in the reaction, which is what we find by solving for the limiting reactant, in this case, 64.23 grams of iron.
Subtract 64.23 from 78 and you'll get 13.77 grams of iron.
We learned that limiting reactants determine how much a reaction can occur.
And we also need to remember, in case we're doing stoichiometry, that you want to make sure that you're in the right unit, right? So we want to be converting back from moles to grams or grams to moles when necessary.